Welcome to the Magical Quantitative Analysis Lab, including precision, accuracy, titrant, indicator, and drops. These words will become familiar to you by the end of this video as you titrate your way to victory. To protect yourself, you will need a lab coat. Protective eyewear, and of course, gloves to protect your hands. Towards victory we head. We are going to do a simple acid-base titration using hydrochloric acid and sodium hydroxide. We will use phenolphthalein as an indicator and the solution will turn pink at the end of the reaction. First, you will need a barrette with a stopcock, a barrette stand to assemble your titration apparatus, and of course Erlenmeyer flask in which the reactions will take place. To calibrate your pipette, pour a small amount of the sodium hydroxide in the barrette and coat the inside. Whenever you're adding anything to the barrette, make sure the stopcock is closed and the hatch is in the horizontal position. Coating the inside of the barrette allows you to make the most accurate measurement readings during your titrations. Allow the sodium hydroxide to drain out. In preparation for your titration, fill the barrette with 30 milliliters of sodium hydroxide as it is secured in the barrette clamp. We recommend the use of a filter while filling your barrette to reduce the chance of spillage. Again, make sure your stopcock is closed and the hatch is in the horizontal position to not allow the sodium hydroxide to drain out the bottom. To record the most accurate measurements on the barrette, make sure that there are no air bubbles in the stopcock. Get rid of the air bubbles by draining the stopcock into a beaker and allowing the air bubbles to be removed. It is important to record the barrette measurements accurately. You can use a note card with a black mark to hold behind the barrette that allows you to read the meniscus more easily. To begin your titration, place the stir bar in the acid solution along with 3 to 5 drops of phenolphthalein. Place the solution on the barrette apparatus and turn on the stir plate. Begin adding small drops of titrant. Now let's first watch an example of what not to do. By allowing the sodium hydroxide to just pour into your acid solution, you are not able to record the equivalence region nor the endpoint. No victory this time. Now let's try that again. By slowly adding the titrant to your acid solution, you can visualize the pink color appear, and this allows you to slow the drops by a fraction so that you can slowly approach as the endpoint gets near. As you can see, as the pink begins to appear in our solution, we make the most accurate determination at which milliliter the equivalence point is reached. No good this time.